Welcome to another episode of AI with Sally, an EE Times podcast that brings you inside my conversations with luminaries of the AI chip industry. Today's episode is brought to you by our sponsor, Infineon Technologies. In this episode, we're diving into the future of the smart home with Gregory Guez, Infineon's Senior Director of IoT and Edge AI. He's in the Connected Secure System division at Infineon. So when it comes to the smart home, we've all heard of connected lights, locks, and thermostats. But the next generation of devices is about much more than connectivity. Thanks to breakthroughs in Edge AI, ultra-low power microcontrollers, and secure wireless standards, our homes are about to get a lot smarter, more adaptive, and more private. I'm very pleased to welcome Gregory Guez to the show to take us through some of the biggest trends in smart home at the moment. Here's my conversation with Gregory. Okay, let's start by talking about smart home kind of at the highest level. Let's talk about some of the trends that we're seeing in the smart home at the moment. I think we all have connected devices in the home by now. I have smart light bulbs. I have the smart thermostat system as well. So a lot of these things are really just connected sensors and connected actuators. I think one of the biggest trends we're starting to see right now is more intelligence coming into devices like this, because we're getting more compute and more AI capabilities in these kind of microcontroller class endpoints. From your perspective, what do you think are the most important things that AI is enabling in the smart home today?
Hi, Sally, and thanks for having me. Well, I think you're really touching on a great point here. As we're seeing AI capabilities transitioning from a cloud-based infrastructure to the edge, basically within the device, without any need for connectivity. I think this elevates the capabilities for the smart home devices to become truly intelligent, not just devices answering to commands, and also not rely on data center to execute functions. I think this is key as we can now introduce this concept of context awareness. What I like to define as context awareness in smart home applications is the device can interpret environmental data, user behavior, and intentionally deliver the right action at the right time. In addition to that, the fact that the decision is made really at the edge, at the level of the device, without the need for communication with the remote systems, really allow for extremely low latency and significantly increased levels of security and privacy. In my mind, this is going to create massive opportunities for companies to release differentiated products to the market.
Gregory, how much of this shift do we think is being driven by hardware? Things I'm thinking about, like the latest breed of microcontrollers with NPU capabilities, or do we think the drivers are more like on the software side, the tooling, education? Like, what do we think are driving these capabilities?
Yes, Sally. Well, I really see Edge AI as a movement right now, and I think the foundation of that movement is really the hardware. The additions of NPU, as you mentioned, like the U55 on PSOC Edge, really meets the requirement of smart home products because they are battery powered, and really the NPU allows to perform AI tasks, inferences in reduced times. This time reduction really translates into reduced power consumption, and for those very power devices. But the reality is Edge AI relies on a more complete solution that needs to be assembled and pieced together. It's really hardware, software, tools, models, and security. I always like to talk about those five elements to be combined together. If one of those components is missing, it becomes very challenging to successfully implement Edge AI into an end product. And what we are seeing is that it can be very intimidating for companies entering that space. And this is why at Infineon, we are uniquely positioned in this market. We provide a total offer, creating a seamless Edge AI journey for our customers.
So you mentioned that devices are becoming more context aware. I think we've always, or for a long time, we've had the capability of doing the ability to do sensor fusion, basically. The idea that devices can combine different kinds of data from different sensors, almost like how human senses kind of work together. But now now that we have all these different types of data, vision, audio, capacitive data, even like different more unusual types of data, like chemical data, we can get
Mm-hmm.
at the edge and process those all together. Can you talk us through how AI is improving sensor fusion at the edge? And maybe you can give us a few examples of the more interesting use cases you've seen.
I think edge AI is a huge boost to sensor fusion. And the reason for that is that it can take streams of raw data from multiple sensors, interpret them locally, and deliver, again, context-aware decision in real time instead of each sensor working in isolation, right? In my mind, this is true intelligence. This is really no more smart devices, smart home. This is really truly intelligent devices. It is similar to how our brain operates when we walk through the forest, for instance. Each sense gives you only one part of the story, but the brain fuses them together instantly to let you know if it's just the wind, a bird, or something that requires your immediate attention. So now if you would apply this to smart home security, for instance, you can combine video, audio, motion, vibrations. All these can be intelligently analyzed simultaneously to make a difference between a family member at the door or an intruder breaking glass. All of this with new level of accuracy that were not reachable before. If you think about it, you can also reduce false alarms from pets, shadows, or background noises. I'm sure if you have gadgets in your home, Sally, smart home devices, you've been exposed to those false alarms. And this is what edge AI and sensor fusing is going to bring in terms of optimization and improvement to the consumer.
Where does it make sense to do sensor fusion? Kind of right at the sensor edge on the sensor in the microcontroller, or distributed more like across different nodes or gateways in the home? Or where do you think the right place to do sensor fusion is?
Well, in that case, I think both can be true, and it really depends on the application. Simple example, in the case of smart doorbell, ideally decisions need to be made on the spot at the level of the device. So we're really talking about the application microcontroller here, making the decisions based on data received. But in the case of smart thermostat, for instance, well, the decision can still be made at the level of the device without cloud connectivity, but you would want nodes to be distributed throughout the house.
Yeah, that makes sense. Can you tell me anything about, if I was a developer, like how would I actually train a model that uses multiple different types of data, on how do I validate it, given that there isn't much kind of public or open source data available that is so multi-source?
Mm-hmm. Yeah, that's a good point. Especially with AGI being kind of new right now, in this industry. I would say what we're seeing is developers don't wait for the perfect data set, right? Because it doesn't exist, as you said.
Yeah.
They create them by simulating sensor signals and collecting data in control environments. They can train models that reflect real-world behaviors, but they can also build on existing AI models for vision audio and fine-tune them for multi-sensor use case. This is actually where it ties back nicely to our previous conversation on edge AI solution and being able to provide tools. For instance, Infineon has DeepCraft Studio, where developers can decide to bring their own data or bring their own model, or even actually get ready models from us. And all of this can be optimized via DeepCraft Studio on hardware platforms such as PSOC Edge, a microcontroller, for instance.
So power efficiency, we can't really talk edge without talking about power efficiency, which of course is another critical constraint. A lot of devices at the edge in the smart home are battery operated or have a very kind of tight energy budget, especially if they need to be always on, like it's wake word detection or something. How far have we got with optimizing AI for these very low power domains? For example, if it was a coin cell powered device, let's say, but then on the other side of it, even if something is a mains powered appliance, a washing machine or something, why is it still important to minimize the energy footprint that AI takes?
Yeah, good point. So I think AGI has made huge progress in optimization for ultra low power domains. This is only the beginning, and particularly critical, just as you mentioned, for battery powered devices that we often found in smart home or wearable applications. The devices now can run meaningful inferences thanks to optimized lightweight models and the dedicated NPU. I keep on coming back to the U55 on PSOC Edge, but that's really the state of the art in the industry right now. So really, the fact that you're running inferences really fast using the NPU really reduces the battery power that's going to be consumed, for this action. Now, when you talk about appliances, I see it, or line power devices, mains power devices. I see it from two angles. First, the power you're going to be using matters because low power means less heat, longer product life, and greater home. But what is really important here, Sally, is Edge AI. It's about enabling smarter, more sustainable experiences at scale because you're not relying on superpower-hungry data centers. So I think it plays a very central role in decarbonization, globally.
Definitely a worthy goal. So you mentioned that the PSOC Edge series has the ARM Ethos U55 NPU on chip, which is something we've discussed in previous episodes. But how big an influence is this hardware acceleration on the power footprint compared to other types of software optimizations that we could do?
I think hardware acceleration and algorithm optimization really go hand in hand. NPU delivers huge gains in terms of speed, which, as we discussed already, converts into power efficiency, making inferences possible on small battery power devices. But without algorithm optimization, even the best hardware would be underutilized. And that would also increase the system cost because if you think about those big models require larger memories, which of course has a cost at the level of the chip. We know that smart home devices are particularly sensitive to cost, especially if you want to reach mass scale deployment. So this is really the best of both worlds we're talking about here. And this is why really in my mind, MCU make total sense for smart home applications versus NPUs. They are cheaper, they are more power efficient, and now thanks to NPUs, they can really run inferences very effectively.
Yeah, that makes sense. Okay, one thing we can't not touch on is privacy, a huge issue for smart home devices. Previously, obviously, we needed the cloud to do AI in these kinds of devices because we needed the compute and we needed the memory as well in the cloud. But now that we have these advanced NPUs, we're seeing more inference going just onto the device. From a system design perspective, can you tell me how does doing the inference at the edge help with privacy? We're kind of minimizing data exposure, but we're also reducing the attack surfaces, aren't we?
Yeah, so obviously, local inferences at the edge, as you described, keep sensitive data in the device. That is assuming you have actually secure storage. This definitely minimizes the risk of data leaks and protects privacy by default, right? At the same time, processing data locally reduces the attack surface because now you have less or no data in transit and definitely fewer points of attack for hackers to intercept those data. Now I mentioned the need for secure storage on the device. And this is why chips like PSOC Edge, running those Edge AI applications come with PSA level 4 certification.
Despite the trade-off in privacy, though, are there use cases where you think some kind of hybrid cloud and edge AI still will make sense for the home?
100%, Sally. I mean, hybrid cloud and edge AI can make a lot of sense in smart home application. Edge AI can handle instant decision, like for instance, you turning the lights when you enter your bedroom, where the cloud will be processing heavier tasks, like analyzing long-term energy usage or delivering software and model updates, right? Smart thermostat is another good example. Adjusting temperature can be made at the device level, whereas household data analysis can be made in the cloud. So I really believe that's going to be a combination of both, the hybrid cloud and edge AI. That's the future of smart home applications.
Yeah, I agree, actually. Related to privacy, you mentioned the PSA level 4. Security is a huge, huge challenge as we push intelligence into these billions and billions of endpoints in everybody's homes. AI models, from the device maker's perspective, are really expensive to develop. We need to protect the firmware and the data pipelines in case anybody's tampering with it or trying to get access to it. Can you tell us about what are the main attack vectors that you're seeing in AI-enabled smart devices like smart home devices, and how do you address those risks?
Yeah, good point, Sally. Well, first there is the base, right? Which is going to be your typical malware injection. And this is traditionally prevented via secure boot and root of trust, validating basically the authenticity of the firmware being executed. Malware injection is an attempt to alter the firmware in order to gain access to keys, private keys, secret keys, or sensitive information, or modify its behavior. Think, for instance, denial of service for a security sensor or a glass break detector, right? Then you would just compromise the system. But what's really new with Edge AI is we are now seeing attempts to actually reverse engineer AI models. Protecting them is crucial because they have become highly valuable IPs for companies and significant opportunity to create differentiated product. So again, this is where having secure storage that would include tamper detection, countermeasures, in addition to secure boot, is key to address those risks and potential vulnerabilities. And those are the reasons why we developed PSOC Edge with security by design from the beginning and are able to achieve PSA level for the highest security level from PSA.
I mean, looking a bit further into the future, maybe this question is a little bit premature, but post-quantum cryptography is something you're starting to think about in the microcontroller industry, or are we looking a bit too far into the future now?
Mm-hmm. Well, I think it's actually not premature at all, but let me expand a little bit on that. The industry is moving quickly to secure MCUs against post-quantum cryptography actually threats. We're designing lightweight algorithms, dedicated hardware accelerators with countermeasures, all of this with reducing computational override in mind. If you watch the news recently, Infineon actually took a significant leadership position in that space when we announced PSOC Control C3 performance line, MCU microcontroller that is post-quantum crypto resistant. I mean, for us, because we are a leader in security and payment, this is really only the beginning. And you can expect all our MCU portfolio to be implementing PQC, post-quantum crypto, security, and evidently our family of secure authenticators such as Optiga to offer peace of mind to our customers. This is really important, Sally, because we know that PQC will be happening in the coming years. I don't know, I hear 2030. I do not really know, honestly. but I'm guessing, I don't have a crystal ball, 2030. but really, think about it. Depending on the life cycle of the end product, the cost of achieving PQC resistance could become pretty steep and pretty overwhelming for company. We are in 2025. If your life cycle is going to be more than 5 years, you might be facing retrofit, you might be facing recall. This can be incredibly expensive and can be very costly and can be massive burden for the companies. So in my mind, company needs to really consider the impact of PQC now in order to be ready for Q day.
Yeah, it was reassuring to know you've already got it under control. I think from the consumer perspective, or from my own perspective, the biggest headache that I've experienced in my own smart home, trying to install smart home devices, is that every company, all these device manufacturers basically have their own smart home ecosystem and they do not work together, and it's confusing. I think historically these proprietary ecosystems that they have really fragmented the market, and it's been frustrating for developers and for consumers. Enter Matter, which holds huge promise, I think, in terms of interoperability. But now Matter is also introducing new requirements around authentication, provisioning, low power operation. Tell us a bit from your perspective about how you see Matter changing the design of Edge AI or smart home devices.
Yeah, it's a big impact. Connectivity in smart home devices has always been a burden to implement and deploy. Big burden for developers, I would say big burden for users as well, to some extent, when you want to commission your device or provision your device to the network. But really with Matter and the standardization of commissioning and communication at the application layer, it's becoming a baseline requirement. So what that means now for company and developers is they can focus on the true value, which is going to be differentiation through intelligence, like smarter sensing or local AI-driven automation. So in summary, I would say Matter is creating the communication pipeline and Edge AI more like the personality of the device. And what's really interesting, Sally, as well, what I'm noticing now is we're also anticipating home appliances manufacturer to integrate the Matter network and join the smart home ecosystem, which obviously is going to benefit consumers. I mean, I'm sure you have home appliances that have Wi-Fi connectivity, and you will see, depending on the brand, they have their own kind of application, they can have their own ecosystem. But all of this is going to be basically converting to Matter, and that's going to really make everything more way smoother and easier to actually enable and use.
How mature is Matter? Is it ready for these device manufacturers to adopt it, or are we still in this kind of early ramp phase, or what level of maturity are we at?
All right. So you really want me to create controversy? But okay.
Yes, please.
No, you will get a lot of comments for that. But anyway, more seriously, I'm just giving my opinion, my 2 cents. From what I'm seeing, Matter is gaining momentum, but we are still in the early ramp phase. I think Matter definitely helps building confidence, both for manufacturers and the consumer, both sides of the equation. I would say positively promises a unified, secure, and reliable standard across smart home ecosystem, which, as we discussed, would make the user experience much smoother. We are not fully there yet, but the foundation is solid. And I'm convinced the next few years should be very transformative for Matter.
That wasn't that controversial. Thank you. I know you said you don't have a crystal ball, but if I can ask you to look a bit further into the future, maybe 3 to 5 years, that's about as far as into the future as we look with AI. Where do you see the biggest kind of step changes happening in the smart home? Is it going to be hardware, NPUs or sensors, or is it going to be more in the software stacks and development tools that let us actually build and deploy these devices? And what kind of new features will people begin to notice in their new smart home appliances?
Yeah, so I think in the next 3 to 5 years, the real change in the smart home is coming from specialized hardware like NPU, paired with better tools that will just simplify deploying and just of AI at the edge and just the adoption overall. Engineer will be able to combine new sensors, efficient models through seamless integration. So I think that's really the next step that we're moving on. The past was all about developing software. Now developing models is really part of creating product. For you, Sally, your home will feel less like being surrounded by gadgets.
Okay, good.
It will feel more like a living companion with the capability to adapt lighting, comfort, and security almost, let's say, invisibly. So it's really what I call the context awareness that's enabled by Edge AI.
Do you think there's any particular vertical that is at the leading edge, that is adopting these changes quicker, whether it's security systems or HVAC or appliances, or is any one type of appliance OEM ahead of the rest on this front?
Well, if I had to rank it, I'm thinking security comes first, because real-time anomaly detection and privacy are everybody's concerns. In second, I would say HVAC and smart thermostat, because again, smarter climate control makes home more comfortable, but also helps with decarbonization. And decarbonization is a huge global challenge that actually Infineon is taking on.
I have to ask, given our conversation on Matter as well, do you think for developers, is the situation going to improve? Are they going to be able to build something and deploy it across different ecosystems in the home? Or do you think fragmentation is still going to be a challenge for us in the next few years?
Yeah, so I think developers dream of, I'm going to say, build once, deploy everywhere future. Mm-hmm. But the reality is fragmentation will remain a challenge for some time. different ecosystems will always move at a different pace. And that means tuning or optimizing for each environment. One thing that is sure, though, Sally, is no matter how the landscape evolves, developers can count on Infineon to be right there at the edge, supporting them every step of the way.
I think that is the perfect place to finish. Thank you so much, Gregory, for a really fun conversation.
Thank you, Sally.
Thank you so much, Gregory Guez, for the fun conversation about trends in the smart home with Edge AI. This episode of AI with Sally was brought to you by Infineon Technologies. Thank you very much, Infineon, for sponsoring us. If you want to learn more about Infineon's PSOC Edge products, DeepCraft Studio, or Infineon's other embedded AI offerings, please check the links on the podcast page at eetimes.com. That brings us to the end of the episode. Please tune in again next time for more conversations around AI silicon and systems. If you're listening to this on the podcast page at eetimes.com, links to articles on topics we've discussed are shown on your left. AI with Sally is brought to you by Aspen Core Media. The host is Sally Ward-Foxton and the producer is James Eade. Thank you for listening.